A very warm welcome, everybody, to the second expert round in this year's Predictive Analytics World on Climate. So in this 1 hour now, we will talk about CO2 and waste reduction related to predictive analytics. And without further ado, we will start with our first speakers. Daniel, I bring you to the screen. Hello, Daniel.
Hello.
Short introduction to your side. You are the lead of the data science team at Trax, and you will explain ideas and technology behind your artificial intelligence solutions to stakeholders in and out the company. You are, from your background, you're a quantum chemist, did a lot of fundamental research in that field, and then having been to research basically a decade where you have been managing research teams for quantitative modeling. So looking very much forward to your contribution. The floor is yours.
All right, thanks a lot for the invitation. I'm grateful to get the opportunity to speak and tell you a bit about Trax and what we're doing and what we believe is most important in data science. Let's just a quick idea of what Trax is. We are an AI company, 3 years old now, with 15 employees, and our headquarters is in Berlin, Germany. Trax is active in the logistics industry, and our vision is to increase efficiency and save resources in the road freight industry. And we'll talk a bit about that. Just to give you an idea about CO2 emissions in general for companies, due to international standards, you want to subdivide your CO2 emissions in basically 3 scopes. Scope number 1 is what you're directly emitting. So let's say you have a car, right, or a truck or whatever, and then obviously you're emitting some CO2 whenever you drive. There are also the scope 2, the indirect emissions, that is mostly electricity, which you usually need to just run your operations. And scope 3 is the indirect emissions that come from upstream or downstream activities, which is mostly transport. By large, it's transport. Whenever you want to transport something to your company or you want to transport something away from your company. And this is done then with trucks, but can also be airplanes or ships or also trains. In principle, everything. We focus currently on the road freight. So let's say the most important question that we had at the very beginning when we started this whole thing was to say, okay, if our mission is to increase efficiency in the road freight industry, we have to answer the question, what is efficiency, right? And efficiency in the road freight industry is usually measured by just the average fuel consumption of a truck on a given distance. So in Europe, we like to say so many liters of diesel on 100 kilometers. In the US, they often say so many miles on the gallon. Whatever your preferred unit is, that is just a consumption rate. And the consumption rate is obviously very dependent on the trip you're doing, right? Are you going uphill against the wind with a fully loaded truck? Then your your consumption rate is probably very high. Whereas you're going downhill with tailwind and an empty truck, then it's probably low. If you're going in a city, with a lot of traffic and stop and go and traffic lights, it's probably high. If you're going on highways where it's pretty empty, it's probably low. However, this doesn't really tell you whether you're efficient or not, right? You can have a low fuel consumption, but you might be not efficient. You may have, there are maybe opportunities to go even more efficient. And so that was our very basic, very first question. And what you notice here is actually it's not directly a data science questions or predictive analytics or anything. It is a very businessy question. Okay, and I think this is a good thing. You should start with business questions and then go into data science and answer them. And so this is how we answer this question, what is efficiency? We make a thought experiment, right? We take a particular trip that we are interested in and want to find out whether we were efficient. In our thought experiment, we can do anything we want, so we let all other trucks that we know drive on the exact same tour. And with exact same tour, we mean the exact same conditions. So the weather is the same, the traffic is the same, the load is the same, obviously the route is the same, and so on and so forth, right? Everything is the same, but the truck, okay? And if we do that, then we have a relative efficiency, right? We can compare all trucks to our actual fuel consumption. And if you do that a lot of times with many, many different trucks, you will get something like Gaussian distribution or normal distribution, people call it also, right? And I'm sure you've all seen this. And now you can decide whether you have been efficient or not by locating yourself, your own truck, and your own consumption on that curve. So let's say the black truck is around here, so that means has low efficiency. Only a few trucks were even better. So it was very efficient because it had only very low consumption. The yellow truck was rather mediocre. It's like smack in the middle. You know, half of the trucks are better, half of the trucks are worse. And finally, we have the red truck, which was very inefficient because it appears that almost all trucks consumed less fuel than this particular red truck. All right. Now, this is the basis of our analysis. Obviously, to calculate the fuel consumption of the all other trucks, we use AI. Right. We use different models. That we start with random forests or SVMs, but currently we are on neural nets. They have a number of advantages, mostly that we have kind of one model that is able to reproduce all trucks, and we don't have to train a model for each truck. All right, this is where the AI comes in, but actually our question and also the analysis is more like a business question and a business analysis. Okay, so that's the first thing that we did, and then obviously that's not all we wanted to answer, right? What is efficiency? That is a starting question, and we want to describe. We have three goals basically. We want to be descriptive in the sense that we want to analyze what happened in the past. Right. So, for example, was I efficient with my truck on this trip? We want to be prescriptive in the sense that we can simulate what could happen and allow the operations to make any decisions. And finally, we want to optimize in the sense that we tell everybody, okay, what should happen and that this should be executed. For all these three different topics, we basically use kind of the same approach that I just explained. Okay, we have our models for, let's say, our different trucks, and I have here the icons for different trucks. We have models also, if you want, for our different drivers. And of course, we have the data, because the trucks, they collect data while they drive. We have this data for the different tours that they drove. Now we can do a descriptive analysis and see, for example, was Alice with her truck on her tour, was she really efficient or was she maybe not so efficient? Very much in the spirit as I explained earlier. We can also have other trucks that are not really in our fleet and other drivers and other routes that are all not really our task. And then we can or let's say future tasks maybe, right? We have a route that we want to drive tomorrow, and then we can be also on the prescriptive side. And here are some questions, some business questions that we like to answer with our approach. So from the descriptive, for example, you can also say, well, how much could I have saved on the trip, right? That's the question that an operator will ask, and there's a clear answer to it. So, well, if your truck is here on the normal distribution, then we know it could have saved pretty much that much, right? And there are other trucks that only consumed that much fuel. So you consumed that much, and the difference is how much you can save. So that's a good answer to an operator, to a business owner. And to say, okay, first of all, maybe your truck was not efficient, and second of all, well, you could have saved so much. If it's maybe just less than 1%, he might not care, right? But if it's more than 5%, it is probably very important to the business owner. The next question we could ask is, okay, now I know that I was not efficient and I know that I could save, but like how, right? What's hurting me or what would be good for me? And again, what we can do is we look at the normal distribution here, and we look at all trucks that are good, right? Let's say in this end of the tail, and we find what's unique for these trucks, right? Maybe all of these trucks are of a particular brand, or all of these trucks have particular brand tires, or all of these trucks use a certain pressure in their tires, or whatnot, right? And similarly, on the other end of the tail, you can do the same analysis, and you can have a look and say, okay, all these trucks are, for a particular brand, so maybe that is not a particularly good brand for my task here. So what we can really tell our customers here, we give them an idea of how can you save, right? Not only how efficient are you, not only how much can you save, but you can also say something like how can you save. I also have a quick example for the dispatch, right? So let's say tomorrow you have different tours that just need to be run tomorrow, these 3. What we can do is we can simulate this truck with Alice on this tour, or this truck with Alice on this tour, or this truck with Alice on this tour. Or, of course, this truck with Bob on this tour, this truck with Bob, this truck, or with Cyril, right? So we make every combination, every truck driver combination, and have them drive on all possible tours that are scheduled for tomorrow. And then we find the best combination. And finally, we will say, okay, this truck with Bob on this tour, this truck with Alice on this tour, and this truck with Cyril on this tour. And this will be the best dispatch. This is how we help our customers to save. For them, it's mostly about fuel because that's their money that they have to spend. But in the end, what they also save is CO2 emissions. And that is something that we then measure accurately and report for them and also for their customers, the shippers. This is what Trucks does. And I have let's say a short summary how we do things and 3 take-home messages still for you. So we start with the business questions, and only then we do the design, train, and test of ML models to then optimize the operations. For us, it's really important to start with a business question and not just with data science, even though that is obviously where the whole fun is. So the take-home messages, number 1 is we put natural intelligence before artificial intelligence. That means that we analyze our problems before we even think about any model, right? We don't even, let's say, analyze the data in very depth. We just try to analyze the problem first. And as I pointed out at the beginning, like what is efficiency? We started that without even really thinking about artificial intelligence, right? And we really had this idea of modeling our different trucks before really going into any deep data analysis. So natural intelligence, meaning we think first and only then the computer starts thinking. The second message is science versus data. Again, we say, okay, science, meaning the very analytical thinking, the very organized and structured analysis is more important than just doing some, running your data through your favorite pandas routines or seaborn routines or whatnot. We believe that helps a lot. And finally, we use the whiteboard before we go to the keyboard, meaning that we sketch out what we want to do and analyze that first. And only then, after we are done and it's clear in our heads, only then we move on and become the real data scientist and do all the neat stuff that you can do as a data scientist. With this, thanks a lot for your attention, and I'm happy to take any questions if you have.
Thank you very much as well. We will take questions at the end in order to not run out of time. That was a great first talk. So let's now go and welcome Yannis to the screen. Here we are.
Hello, everyone.
Here we are. Welcome, Yannis. So, Yannis, thanks for participating. You are a data scientist at QuantumBlack, which is the machine learning and AI arm at McKinsey. Your specialization in terms of sector is pharma and finance, as I learned, and you're a quantitative financial analyst by training. So, looking forward to your contribution. The floor is yours.
Great. Sure. Let me share my screen and then we get into the presentation. So here we go. Yep, perfect. Great. Hey everyone. Like in the introduction said, my name is Klaas. I work at a place called QuantumBlack. We are part of McKinsey. We help clients with advanced analytics problems. So usually that means, we help them build some really sophisticated models to solve their hardest business questions. And in this case, we had the opportunity to work together with the Oxford Smith School and work on an asset level model of the global fossil fuel supply chain. And I'm going to get into what that exactly means in just a minute. But first, why should we build kind of a really good model of the fossil fuel supply chain? Basically, what we see is that we have to transition into a post-carbon society. And that means we have to build up a lot of electrical infrastructure and build down a lot of fossil fuel infrastructure. And there's expensive ways to do that, and there's cheaper ways to do that. And those cheaper ways usually come through sensitive intervention points. And to give an example of what that means, you might have a coal mine that supplies 5 coal power stations. And now if you take out one of those coal power stations, suddenly the coal mine no longer has enough buyers for its coal. And, so the coal mine then shuts down because they no longer have enough buyers. But then the other 4 coal power stations no longer have any fuel, right? Because their mine just shut down. And so by taking out 1 power station, you've taken out 5 power stations plus a mine. And this is exactly this kind of sensitive intervention points. Knowing about these points is really important for policymakers who want to evaluate whether they shut down or not a certain power plant, but also for operators who want to know how they can be most intelligent about, shutting down certain places and keeping up others to keep the amount of stranded assets low and to keep the cost of this transition manageable. And so the Oxford Smith School, they did some really phenomenal work in gathering the precise geolocation of all the assets that are involved in the fossil fuel supply chain. So that's all the oil wells, that's the oil fields, that's coal mines, that's, processing plants. It's thousands upon thousands of these plants. You can see it on the map here. They're all around the world. And they gathered the data about where they all are. And they also gathered data about where all the population centers in the world are and how much energy they consume. And what we then did is we helped them build a graph out of this. So we helped say, okay, you have this oil well here, and then you have a pipeline, and then you have a refinery, and all this is kind of connected into a network. And we help you go from these geolocated places into this network. And this is a really, really big network with over 11 million nodes, and there's quite a bit of richness to this network. There's the entire supply chain is in this giant network, and this network is freely available on GitHub. If you look at the paper, you will see also where you can download it. And this allows us to query for these sensitive intervention points. And it allows us to ask a couple of questions, and not just us, but other researchers as well. So I already talked about finding these sensitive intervention points and finding the most efficient way to decarbonize. But also there's questions about robustness, right? So say I have this great strategy to decarbonize. I have this great strategy of taking down that coal plant, or saying we're gonna raise the operating costs through taxes for oil processing in this area, something like that. But of course, there's other players in the game, right? There's other countries, there's other companies, and they might not share the same interests as I have. So we can say, okay, we can play these kind of Nash games where we find that my policy, is robust against whatever the other players do. And finally, we can ask questions about prescience, where we can say, okay, does this model accurately tell us about what's going to happen in the world if we take a certain action, right? Oil prices are going to go up at a certain location if we shut down a certain facility. And so we did some work in that direction already, and we looked at the flows of the three main fuel sources, so oil, coal, and gas. And the way we did that is we looked at the population centers in the world, and we looked at how much they consume, and then we looked at the production centers in the world, like the wells and the pads and so on. We looked at how much they might be producing, and then we said, okay, how can you kind of flow from a production center to a consumption center the fastest? And what's really great to see, although it's obviously just a bit coarse estimation, because we get into what information you're still missing, you see, for instance, that in Europe we're quite good on tracking the flow of oil from Saudi Arabia to kind of Central Europe. In the US, we capture the Gulf Basin quite well. So we definitely capture kind of quite a bit on the macro level. Similar story with gas, although here we get into the limitations of this model that I definitely want to discuss. So the close reader of this map might see, kind of a bit odd that there is no really big gas pipeline going from Russia to Europe, even though that's where all the gas comes from in Europe. And the reason for that is that we don't know the capacity of each individual pipeline. So we don't know if it's a big or a small pipeline. So what tends to happen is that all the pipelines are kind of treated equally, and you never see those mega pipelines coming through, but you see lots of smaller pipelines coming through, which is a bit sad if you want to talk about one particular pipeline, but you still get kind of the macro flows roughly correct. On coal, I think coal we're actually doing the best on. So you very clearly see this big coal train coming here from Australia to China. That's probably the biggest coal export operation in the world, and we capture that correctly. You see a lot of kind of coal coming out of Germany through all places in the EU, and around here you see a lot of rail transport of coal as well in the US. The next step that we can do is we can look at the Sustainable Development Goals, and the Sustainable Development Goals actually outline how much each country has to decrease, or some countries are allowed to increase actually their energy consumption and their fossil fuel consumption. And you see that, for instance, most African countries, they're actually allowed to increase their energy consumption because at the moment they don't consume a lot, actually, because they're quite underdeveloped economies. And so generally people assume that they will need to increase their consumption rather than decrease it. While, for instance, Europe and the US, they will mostly decrease consumption. And we can map this onto each individual line and route, right? So we can say, okay, if Germany is to decrease their fossil fuel consumption, right? Like, what's that going to do to the coal shipment going in and out of Germany? And it gives some really interesting results, some really fascinating views. So for instance, you see this big coal train from Australia to China. Of course, if China's gonna go reduce their dependence on coal, Australia can no longer export that much coal, and that's gonna have some very specific impact, right? So it's gonna be particular harbors and particular routes that are going to be impacted. And if you zoomed in a lot more into this map, you would see exactly which kind of hub and which kind of route is being impacted. And there's a lot of other places. There's some places which are really surprising, where you say, okay, in the US in general, we're going to reduce dependence on coal, but there's going to be very few lines that are not going to be impacted by this so much, right? And so if you're an energy company, you should really probably then shift your investment away from those where you can clearly see that they're going to be no longer needed, and towards the ones where you see, okay, there's going to be more demand in the future. And that's it. That's the whirlwind tour. I'm excited to discuss this later in the Q&A. And thanks you all for listening.
And thank you, Jonas, for sharing this with us. Very exciting work. Thanks for sharing also the paper where people can get more into depth. Our next and final speaker in this hour is now Bosse. Welcome, Bosse, to the screen.
Hi.
You are founder of Cleanhub, which you definitely will introduce us in a moment to highlight what's maybe special in your case is that you are not only passionate about cleaning the oceans, but you're also passionate about sports. You are listed as an Ironman undertaker, and I think that's a lot of fun. That says much about you already, and I give you the chance to present what you are doing. Thank you very much.
Perfect. Thank you. All right, let me also share my screen. Well, yeah, first, welcome everybody. So I will be talking about plastic specifically, and how we can use predictive analytics actually to improve our impact on that problem. The story of Cleanhub is one that came out of frustration. So like I was briefly introduced, we are three software engineers, not software engineers, business people who were just frustrated by the fact that the plastic problem is something so tangible, but seemingly there are just too few and too few solutions out there that can really tackle it. And today we live in a world where essentially 4 out of 10 pieces of plastics that are consumed today end up in the environment. That's a terrifying number that is just mind-blowing to think about. And at the same time, when plastic is consumed, it happens in the households. Afterwards, it typically ends up with landfills, the majority of it. And then from these landfills, it's always one of two things that happens. Either it's being openly burned by people who are looking for metals or any valuables in this waste, or it's carried by wind and rain into the next river, and from there it enters the oceans. So these 11 million tons is the figure that enters the oceans every year, which is something that I'm sure just very few people can imagine. So 1 ton is 75,000 plastic bottles that enter. Just for as a crazy comparison to think about this volume. So Cleanhub, what we're all about is we want to build a scalable way to make a dent to this problem that is significant. And so when thinking about that, there's a few things that are very important. The most important thing maybe is that, well, you need a lot of people, a lot of companies, private and businesses to become part of such a solution to make it work, A, and B, there needs to be a very seamless way and very simple way to take action, and that's what we're building. So here's a nice overview of examples of our stakeholders that we work with. So on the left side here, you see brands that we're working with. So, that are our customers, they sit largely in Europe, they sit in the US, all over the world. Actually, there are in different industries, generally companies who want to be part of such a solution. And on the right-hand side, we have the recovery network of ours, where we work currently in India and Indonesia mainly, where, the companies collect, sort the material, they transport it, and eventually treat it in a final process. And the way we work together with these brands, it's quite, like I said, we tie it to their products. We make it simple for the consumer to understand, and also for the brands to participate, so that with every product they sell, there's a certain kilogram of plastic that we collect in return for that. And the key thing to understand for us is that our mandate in all of this is to make sure that the impact happens with the utmost of transparency and with the highest possible efficiency. That's what we believe is the tipping stone to be able actually to collect so many volumes. You need to have the 120% transparent and trustworthy system. So what we do is we work together with these partners on the ground. They collect the material, they sort the material, and they treat the material from these coastal regions, from the beach, 50 kilometers proximity to the next river or the next ocean. And they use our software in the process. As we see that much of the impact that's happening is sort of dilutes after it has been kicked off, so to say. So if we want to collect 100 tons of plastic and we enter into agreement with the partnership locally, then we want to make sure that we understand truly what happens to the material from the point when it's being collected up until the point when it's finally treated, to make sure that the impact that we verify has truly happened. And that's really our stack. So this is a brief overview of what we work on. So we have this app that is used locally in India, Indonesia, by our partners, who then use this software to track everything that they do. They collect a bunch of data on the way that we can analyze. And then we have the marketplace, where we project all the transparency towards the customers for them to be able to see what's really happening on the ground. And in the middle of that, we have our analytics to make sure we understand whether or not impact truly happened, and that allows us to verify the true impact at the end of the day. I will probably skip this just a bit for now, but how these supply chains look like, I think that's really quite important, is that we typically have two partners. So we have a collection center. So those are organizations that are typically right now in the business already of recycling plastic, and we engage them to collect plastic in these coastal regions. So they collect it, like I said, from beaches, but also from households in these coastal regions, to enable a sustainable impact that is lasting and actually has the highest possible efficiency per dollar of contribution that we get. And that is the overall goal for us. We want to maximize the impact, and the way of collection is actually one of has massive impact on that in the very first place. That is why, for instance, just as an example, collecting plastic out of the ocean itself is just to a magnitude, to a large degree, just much less efficient. As you can all imagine, that takes just much more operations and costs much more per ton of plastic that you want to recover. So the most efficient thing is actually the household collection. That is what we need to develop in the next years in these regions to really have a large scale impact. What we do then, and that is how our app and our software they use, is that our collection partners use our software as some kind of operating system, where we currently do not push other digital systems out of the market. It's largely undigitized, so that's really the first challenge, and that's digitizing these processes. And then they use our app along the way to track everything that they do. So they take pictures of the plastic waste that they collected. They have to weigh the material like a checkpoint system along the supply chains, so that we have full transparency into what happens on mass balance level. Really, what happens to all the plastic that is being collected, where is it, by whom was it touched, and so that we can follow through and understand what's going on. And that's really along the lines. There's naturally like I said, our main mandate is to maximize impact per dollar contribution, and there are several ways in the supply chains how the impact that we want to achieve can actually dilute. And I would say there are two main things that come to mind. So the first is naturally the externality risk, right? So that can be, for instance, in these regions in India, if there's monsoon time, for instance, and there's a lot of rain happening just the days leading up to the delivery of the plastic to the treatment facility, which is the final endpoint, it might well be that 50% of the weight actually is made up of water, and that would obviously, nobody wants to pay for water to be transported from A to B. And so what happens always at the end of the day is that the treatment facility, luckily they have labs and they open up all the bags and they're able then to measure calorific values. They're able to measure water contents in all the deliveries so that they can also insert that into our data. So we want to mitigate the externality risk that can be unsuspicious behavior like with weather, but it can also be suspicious behaviors by participants of the supply chains where perhaps something else than plastic was added into these bags that were collected to increase the volume and basically fraud the system. So we have an interest to understand anomalies, to understand and detect, to separate what is good and what could be bad behavior, and that's currently what we're working on. The other thing is, and this is what externality risk, of course, also goes into, is really the sheer fraud risk by doing collusion or just taking the picture of the same material over and over again. And there is, for us, it's really up to us to design a system that is as robust as it possibly can be in these regions, where we're also then working on making sense of the data that we get to understand this better and be able to formulate some actions that can mitigate that risk. That is how we think about this. And at this stage, actually, I'm already through. Thank you for all your attention. It was a pleasure.
Thank you very much, Bosse, for this really inspiring talk. We have plenty of time for questions, so the audience, please feel free to write your questions in the chat. We will pick them up from there, read them, and post them to the speakers. Maybe until you find your way to writing the questions, I would have to. I would like to ask Bosse, you from a point of your corporate partners you're working with, how they are finally using the validated results. I mean, typically I saw large companies like LafargeHolcim, for instance, they do sustainability reporting in quite some extent. Is it foreseen that there's a structured, systematic way to put those actions and name these actions in the sustainability reports, or how do the companies use the results?
Yeah. So LafargeHolcim is one of our supply partners on the ground, right? Like Heidelberg Cement as well. And they have naturally an interest. I mean, then it's nothing new to them. Also has to be seen. They are burning or like treating waste. Their factories run on a large degree of waste already in Germany and other regions. It's just that in India or in Indonesia, it doesn't happen yet to that degree. So they're already doing a lot on that, and of course we can help with by delivering this tracking. With more analytics and more information around where this material really came from and what the conditions were, and that's something that they're also actually interested in. It's something that we're in progress.
Thank you.
You told me in the preparation call that you have most of your clients are not from Germany or even Europe, but from developing countries. And I'm like to hear also, for example, from Daniel. Is it the same for you guys, and why is this so?
Okay, I can tell you, no, from our perspective, we see our customers are in Europe. This has probably, I think there's two reasons for that. Number one is obviously in Europe, but also North America, we have a highly developed highway system, and truck transport is rather big. The other thing that is important for us, in order to do our job, to do our AI, we need data. And this data is collected from sensors that are only in, let's say, the latest trucks. let's say if a truck is older than 5 years, it probably will not have those sensors. And we can see, let's say, a life cycle of trucks, right? They start in Europe, in West Europe, they move to Eastern Europe, and then they go, for example, to Africa. And so you see the trucks in Africa, they just don't have the sensors that we need. So we could not collect the data that we need in order to do what we want to do. So this is why we are currently basically limited to West Europe or Europe in general and Northern America.
So it's really depending on the specific use case, whether it's relevant.
Yeah, right. This is what we are doing. We need that data, and if your truck does not collect that data and make it available to us, we cannot help. Right? I mean, this is a very basic thing for us. However, I mean, every new truck now has these sensors. So in 5 years' time or in 10 years' time, we will also see those trucks in Asia and also in Africa and in South America. So we can do it anywhere in the world.
Janus, maybe a question to you. You had this nice, huge graph network displayed on the fossil part of the world. Now, as we speak, a similar graph, or at least a similar assets start to penetrate the world regarding the renewable energy. And this is exactly the transition that's happening, right? So is there any sorts of possibility to kind of map these new intermittent sources with the existing fossil energy system and kind of improve the adaptability of, let's say, where organizations or processes get power and energy from through this combination?
Yeah, that's absolutely possible. So this graph that we have is very extensible, and plugging in a new type of source is quite definitely possible. I think there's a couple of really interesting challenges in doing that, right? So mapping the electricity grid, and especially the grid for transfers of large amounts of power is quite hard, because you need to know where those super pipelines, they're not pipelines, but those super wires that can transport all the electricity from the North Sea to the south of Germany really are. So there's some interesting challenges in that, but it definitely fits in, and I think it would definitely be very interesting.
I would like to make a comment that I noticed when I was listening to the other two presentations, and also something that we say at Trax all the time, is that apparently all three of us, we are looking to measure accurately currently. That is our, let's say, our main goal. I can tell that from Trax. That is definitely what we're doing. We first need to measure accurately. What I understood from Jesse and Bosse is also very similar, at least. Okay, I mean, Bosse, you were telling us, how you kind of track it and measure. Yeah, you're measuring really what plastic is where. And I think what we saw from the coal and oil distribution, and also I forgot gas. And you said also yourself, well, we don't know exactly how big the pipelines are and how much gas and oil and coal is going here and there. So you're also currently doing the accurate measurement, right? And I feel like this obviously is the first step, right? You can't reduce what you can't measure. How can you reduce anything if you cannot measure it? So that's the first step. But it's not the last, right? It's also pretty clear we want to go next steps, and we want to improve that and want to optimize that in our different ways. And in our case, we want to reduce just a fuel consumption on the trucks. And I'm sure you guys have also some ideas of what you want to do. But yeah, I feel like currently most of the effort is really in accurately measuring waste, CO2, or all impacting KPIs.
I mean, it's like Mr. Deming said about 60 years ago, you can't manage what you can't measure. And I saw this for different industries when we had the first Predictive Analytics World for Industry 4.0. On the first conference, everybody talked about sensors and Wi-Fi connections within the manufacturing side, because we just first had to measure the data before they can analyze it, and then they can build models, and then they could use these models to simulate actions and decisions. And then we went from predicting outcomes into prescriptive analytics, doing optimization recommendations. And I think this is really interesting to see here that this maturity process is repeating now for the whole climate industry. Yeah,
I think that's exactly right. And I think the challenge of measuring in the climate and waste domains is that you often talk about second order things that you don't really control yourself, but that some other company controls.
Yeah.
And to gain insight into your second order consumption, you need to know so much more about the world. That makes it really hard. Like if you go to the supermarket and buy something, right, how much CO2 is that emitting? Well, you need to know where it was grown. You need to know how it was shipped, maybe even which truck it was shipped with, all these things, just to know how much CO2 you emitted there. And that makes measuring a real challenge in this case.
Yeah, I think that was
you bring up a really interesting point here. I mean, this is really right in what we're doing, right? So let's say in our case, we have a bit the advantage that we have these sensors of fuel consumption, and fuel consumption pretty much directly translates into greenhouse gas emissions, depending on your fuel, right? You can have different types of fuels, LNG, CNG, diesel, or even electricity. So we have a bit an advantage, let's say, us trucks as compared to you two guys, because I feel like this is a lot more difficult to actually measure. But you also have, I mean, what you just mentioned, right? The shipper would like to know, or the consumer would like to know, and there's many players that have to chip in to actually calculate and measure the CO2 or greenhouse gases, let's call it in general, emissions, right? So I think it's a big task. It's not easy, and what we are trying to do is we are trying to be a bit of a platform for the carriers, as we call them, so fleet owners, and the shippers, meaning their customers, that want something to be shipped from A to B.
Yeah.
So what about the issue of data sharing? Is it the normal in your industry? Because I know it for example for the Industry 4.0 space, there is, for example, this Industrial Data Space Association, which enables companies to share their data. What is the state in your business?
It's a bit difficult because the carriers, they own fleets, and they have a high price pressure. Okay, so they do not want to share too much information with their customers because they're afraid of more price pressure. So they like us in the middle, right? Because we take their data and we calculate the CO2 emission per shipment for the shippers. So the shipper only knows, that freight piece has, I don't know, let's say 5 kilograms of CO2 emissions. And it doesn't tell the shipper a lot of information for the price, for example. So the carriers like that we are kind of a middleman there, a trusted middleman. We have some accreditation for international reporting as well. So that comes in rather easy. I mean, overall, it is an industry in development, right? It's an ecosystem that is building currently, and you never know how it will look in 5 years, and maybe things will change. But currently, we see this is a good point to be, right? Being kind of a platform, having accreditation certificates, and being like a trusted middleman in some sense, and obviously delivering value beyond the trust, right? By calculating the CO2 emissions.
Also, it's the same for your company, for your industry?
Yes, I mean, I think we have a similar problem that there's just a lot of data out there that is in silos, and there's a communication issue basically to get, to connect the dots between all this information. I think that's also to the large degree that what we are trying to solve, right? For this circular economy, if you think about plastic as, obviously the biggest impact also for CO2 is to keep plastic in the economy right, and to return it back, and that is the goal, and that it has the biggest impact on CO2 as well, if we can reuse it more often than we currently do. But also for that, you need information. Basically, the information flow stops after the consumer has purchased the product, and from then on, it's basically in silos. So we need to connect the dots, and we need a unified information layer, and that's what we're trying by digitizing these waste managers in those regions to basically pick up information again once the material was picked up again, and then from then on follow it until it's back in the economy again. But yeah, very much so. I would say it's a general. I think it's also a very interesting point that we see we all sit at the same table and work on measuring, which also at this point has by far the largest impact, right? Understanding what information do we need, and making sense of that first.
Okay, there is one question by Antje, one of our speakers, directed to Daniel. Can you elaborate on the features that affect fuel economy in more detail? How do you deal with them when they refer to the driver and not to the weather truck or wheel model?
Yes, okay. So this goes in technical things here. So the trucks, they collect data which we would call the status data of the truck, right? Something like which gear are you in, or what's the speed, or things like that. And obviously those are the most important features, right? The speed by far, right? I mean, the faster you go, the more you consume. Very, very simple, right? And also going uphill and things like this. Weather makes a bit of an impact, depends on the weather also. What we see is heat makes an impact because the drivers use the AC, which consumes just, and in winter, if it's too cold, the drivers use the heating, and obviously that consumes as well, right? We do have also a few features that kind of describe the driver. For example, which gear the driver is driving in is kind of something about the driver. Also, we get information about the gas pedal, actually, like the percentage, how deep it has been, and that obviously is the driver. And what we're trying to do is we have kind of features. I like to call it a bit an embedding, even though I know that's not a very precise use of this term. But what we do is kind of we use a number of different features. For example, also how long has this driver been driving, right? Is this a newbie? Right, first time on a truck, or has been doing this for 30 years, let's say, right? And this together, a number of features put together, like a one or two features as kind of an embedding, which we learn, obviously, right? And we have the same for the truck, as the truck itself, right? And then we have status data like speed and stuff like this, and weather, and all together they form a neural net. I hope that was answering the question.
So maybe you exchange contact details and
absolutely.
Unfortunately, we are running out of time, and already we have the next speakers in the backstage area. Yes, thank you very much. By the way, the next expert round in about 8 minutes or 7 minutes will be about the topic of data acquisition. I think we all learned from your presentation that this is a very important topic. So yes, stay tuned, and thank you again.
Thank you.
Thank you very much, all of you.